you are welcome to this class. In this class, we want to look at highest common factors, which is HCF. So we'll be looking at the meaning, methods, application. If you look at the videos you have watched before, and if you have not watched, you can check the description. They are prerequisites to this video. So if you have not watched, go and watch them. So because there are some things that we've discussed there that will be applicable in this video. So in this case, we want to look at the meaning of this. Then we want to look at the methods that we can use to solve problems on this. Then we look at application. So let's look at meaning. So what this means is that highest common factors. So that is we might have some two or more numbers that we want to get their factors, and the factors that is common to both or all of them, we list them out. Then we also look at which one is the highest. Which one is the highest factor that is common to all of them? The highest factor that is common to this number and this number, that is what we call highest common factor. So we look at this, we look at the methods and we can use to solve it, and we look at application. So let's start with the method. So let's start with the method. We have the first method. The first method, method 1, will let us appreciate the meaning of this. So we're going to start from, let's say for instance, example. Find the HCF of 48 and 64. We want to find the highest common factors of 48 and 64. So the fourth method is factor method. We want to use factor method. So that is, what that means is that we are going to list out the factors of both numbers. If there are more than this, you list out their factors. So the first one we have 48. Let's add the factors of 48. 1 can divide 48. 2 can divide it. Can 3 divide it? So how we need to check. So check it. 4 plus 8, that gives us 12. So because it's 12, 3 can divide 12. That is what? 3 can go. 4 can divide it. That is 12, which is what? 4. What can divide? 5 cannot divide because it's ending with 8. What about 6? Can 6 divide this? So it is combination. Since 2 can divide it, 3 can divide it, so 6 can divide it. You can see, that's why I said, if you have not watched the video that I discussed divisibility rule, go and watch. You can see how you are connecting it. Very easy. So for you to get 6, you know that this and this. So if this can divide it and this can divide it, then 6 can divide it. Then for 8 can also divide it, because 48, 8 can divide it, 8. So go and check the rule. Then 9 cannot divide it, because when you add the two numbers together, it's this 12, and we cannot use 9 to divide 12. 12 is not a multiple of 9, so in that case 9 will not go. 10 cannot go because it's not ending with 0. 11 cannot go. Then 12 can go. 12 is divisible. 13, no. This 13 cannot go in this. 14 go? Yes, 14 can go. 14 cannot go in this one. So what the next thing is just to look at, okay, 1 and 48. 48 can go. 2 and 24. 3 here, 1. 3 here, 1, right? 16, that is 16. So 4 times what gives? 4 times 12 gives 48. 6 times 8 gives 48. So this means these are the numbers that can divide 48. So we have 16, we have 24, and we have and 48. So we have listed out the factors of 48. Then we go to 64. We go to 64. 1 can divide it and what? 64. So let's do that way. 2 can divide it. 2 divided by this, that gives what? 32. Right? Can 3 divide it? Yes, 3 can divide. Can 3 divide it? 6 plus 4. That gives 10. So 3 cannot divide it. What about 4? 4 can divide it. 4 here 1. 4 in 24 is 6. So 4 can divide it. So that is 16. 4 in 6, 1. Remainder 2 in 24, 6. Then 5 cannot divide it. 6 cannot divide it. 7, can 7 divide it? No. 8 can divide it. 8 times 8 is what? 8. What about 9? 9. No. So these are the numbers that can divide 64. Yes. That is 16, 32, and then 64. We have lifted out this one. So the next stage is to look at the common factors. So we have looked at the factors. Then the next stage is what? Common factors. We call it CF. So what is common to this and this? The factors that is common. 1 is common. We write 1. 2 is common. Put out the 2. 4 is common. Put out 4. What is common again? 8 is common. We put out 8. Then 16 is common. We put out what? 16. What is? Nothing again. So that is that and that. So the next is that look, out of the common factors, which one is the highest? So that will lead us to HCF. That is what? HCF. So which one is the highest common factor there? That is 16. So that means that 16 can divide 48 and can also divide what? 64. So if they ask you what is the highest common factor of 48 and 64, that is 16. So if the question now comes in this way, we try to look at application. What is the number? What is the number that can divide 48 and 64? What is the highest number? What is the largest number? What is the biggest number that can divide 48 and 64? They are indirectly asking you highest common factors. So we will be looking at application now. So that is after I've looked at all the 3 methods. So we now look at the second method. Second method is what I call method 2 now. Method 2. Method 2. So that one is the method that we express just like what we just finished. What we finished in the last video. Last video we finished, we expressing number as product of its prime factor. So we are going to use prime factorization method. We can call this one prime factorization method. Prime factorization method. Prime factorization method. So what we're going to do, we're going to express this as product of its prime factor. So expressing this, let me use this place as my workspace. So now 48 now, I will express this as product of prime factors. That is 2 here, that is 24, 2 here 12, 2 here 6, 2 here 3, 3 here 1. So that means 48 will be 2 times 2 times 2 times 2 times 3. Then I'll go to 64 again. 64. So 2 here, that is 3. 2 here, 2. 2 can go. 2 here, 1. 2 here, 6. 2 can go. 8. 2 can go. 4. 2 can go. 2. 2 can go. 1. So that means 64 is 2 times 2 times 2 times 2 times 2. 5 places. So the next stage is now to look at, okay? We have done this. So let's now look at what is common here. What is common? Common factors here. This, and this. So that means we have 2 times 2 times 2 times what? 2. So common factors. So the HCF will now be the product of all these ones. So HCF will be 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Is it not the same thing with our answer here? You can see. That's method. This prime factorization method. Expressing each of the number as product of their prime factors. Then look at what is common. The common factors there. So what is common to this one and this one? Then write them out, find their product. You get your what? The HCF of that number. Then the last number, the last method. Let me do it here so that I will not waste time. The last method, method 3. Method 3 is the shortcut method. Shortcut method. You are solving if what the problem is given in an objective multiple choice question. It's not, you are not expressing it. It's like this. So you can use this method. It's the fastest method. So what you are going to do is just have 2 columns here. If there are more than 2, you have 3 columns. So we have rank 48 here, rank 64 here, right? So we now look at number that can divide both. If you don't have, we stop. Whatever we stop, if there's a number that can be stopped there. So 2 can divide both of them. 2 here is what? 2, 4. 2 here, 3, 2. 2 can still go. That is 1, 2. That is what? 16. 2 can still go 6. 2 here, 8. 2 can still go. This gives 3. This what gives 4. There's no number that can go in 3 and 4 at the same time. So in this case, we stop it. That is the end of it. So what we're going to do now, we just multiply this with. So our HCF now will then be what? 2 multiplied by 2 multiplied by 2 multiplied by 2. That gives what? 16. See the same answer. So that means we have 3 methods. Any of these methods, method 1 and 2, you can adopt them in the theory. But just for advice, you go for this one because it's faster. This one is just we're repeating this and this one, this method 2, and it's faster. And this one is a bit long. You can see when we're doing it, we have to be checking the numbers one by one, which will take our time. So our advice in exam. So if you have large number, you can go for this. If it's subjective, go for this. Right. I hope that is clear. So that is, we're going to stop here now. So we then look at application. We'll look at application next. So we want to look at application to this HCF right now. So let's look at this. So 2 rows are 12 meters and 16 meters long. The rows are to be cut into pieces of equal length. Find the maximum. Take note of this. Take note of this. Maximum of each piece. Now, I will do it without applying this. Then we now compare the two and see if we're going to get the same answer. It means we have a rod of 12 meters that we want to cut into equal length. And also have at the same time 60 meters that we want to cut into equal length. So which means cutting into equal length, as if we are looking at numbers that can divide 12, all the factors of 12. Then we also look at all the factors of 16. So that means let's start with 12. So if you look at 12, if you look at 12, so we can divide it 12. Let's assume this is the rod. This is the rod. So the factors of 12 are 2, 3, 4, 6, and 12. So we only look at these 4. So we have this. We have another one. We have another one. So we have this. This is the cord of 12. Of this, they are 12 meters long. Now we want to divide into 2, that each of the piece will be what? 2 meters each. So this we are going to divide this one into 6. So let's have 6. Good. 1, 2, 3, 4, 5, 6. That means 2 meters, 2 meters, 2 meters, 2 meters, 2 meters each. This one, that is going to divide into 4. Right? Into 4. So that is 3, 3, 3, 3. So we divide it into 3. So that is 4, 4, 4. Then this one we divide into what? Into 2. So that is that on 12. So let's now go to 16. So 16, this is the 16. The factors of 16 are 1, 2, 4, 8, and 16. So we look at these 3. So we are going to have 3 in this case. We assume this is 16 meters long. So we have divided this 2, 2, 2. 16 now be it's going to we are going to have 8. 8 of this 16. That will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that will be 1, 2, 3, 4, 5, 6, 7, 8. So this will be into 4. 1, 2, 3, 4. That is, this will be 4, 4, 4, 4. Then this will be 2 into 2. 2. Now, if you look at this is a 6, 6. If we look at this, this one is divided into how many places? This we have 4, 4, 4. And we also have 4, 4, 4, 4. This is 3, 3, 3, 3. We don't have 3, we have 2. We don't have 6 here, we have 6 here. So which one is common to them? Only 2 and what? And 4. That is common. 2 and 4 is common. So which of these one is the highest? Because the question is maximum of each piece. So maximum of each piece here, that will be common to both of them will be what? 4. So if you divide it into 4, 4, 4, so which means the rows will be 4, 4, 4, 4, 4, 4, 4. So making how many of them? 7. So which means we can divide this one into 7 of 4 meters each. We can divide the rows into what? 4 into 7 of 4 meters each of each piece. So that the maximum piece that we can have here is what? 4. The highest common factor will be 4. So which means if they ask us this, so we look at this, the maximum of each piece, like the maximum length of each piece is what? Is 4 meters. So which means indirectly the question is asking us to find the HCF of what? Of 12 and 16. So take note of this. Anytime you hear this, you have two numbers and you're looking for maximum of something between the two of them. You are talking about HCF. So which means you're looking for HCF, which we have treated 12 and 16, 2 here, 6, 8, 2 can still go, that is 3, 4. So that is HCF is what? 4 meters. That is the maximum length of each piece will be what? Will be what? 4 meters. So that is that on this one. I will look at one more question on application. This is another application question on HCF. Now let's read the question first. So because we can also say this is a poor problem. So a bookseller has 175 English books, 175 English books, and then we have 245 science books and 385 mathematics books. So he wants to sell the books in a box, subject wise, in equal numbers. That is, you're going to have equal number of English in all the boxes, equal number of science books in all the boxes, and equal number of math books in all the boxes. So what will be the greatest number of boxes required? So how many boxes are we going to divide, put all this one into? So the greatest, take note of it. So you can remember in the first one that one was talking about maximum. So anytime you hear the greatest, maximum, largest, we are referring towards HCF. So the first thing you need to do is find the HCF of 175, 245, and 385. That will tell us the number of boxes that we're going to divide all these ones into. So that means, let's make use of this. 175 then 245, then move on to 348. So we have 5 can go because all of them ends with what? 5. Or let's check if 3 can go. 2 cannot go. 3, this is 8 plus 5, that is 13. 3 cannot go. So let's use 5. So 5 here is 3, remainder 2, that is 5. 5 here, 4, remainder 4, and 45, 9. Right? 5 here, 5 here, that is 7. Remainder 3 in 35, 7 here. So what can go? 5 cannot go again. Here, 35. 7 can go here. 7 can go here. 7 can go here. So we can use 7. 7 here is 5. 7 here is 7. 7 here was 11. So do you have any number that can go again? So this is the highest number that can divide this one into equal parts. That can divide this one into equal parts and can also divide this one into equal parts. So that's the highest, the greatest number of boxes. That's the number we can divide this into. We can also divide this one into, we can also divide this one. That's the HCF. So that means the number of boxes that we can have, the number of boxes will be what? Will be 35. So if we have 35 boxes, so how many English? The question asks us also find the number of books for each subject. So for English now, number of English in a box will then be 175 divided by 35. The number of science books in a box will be what? 245 divided by 35. The same thing, number of math books in a box will be 385 divided by 35. So this gives something. Let's use our calculator. Find the answer. That will be 175 divided by 35. That gives, we're going to have 5 English books, and here 245 divided by 35. That gives 7 books, right? 7 science books, and 385 divided by 35. That gives us 11 books. So which means in each box we are going to have 5 English books, and we're going to have 7 science books, and we're going to have 11 mathematics books. So adding everything together, this is 18, that gives us 23. We're going to have 23 books. There will be 23 books. There will be what? 23 books in a box. So we're going to have 23 books in a box containing 5 English books, 7 science books, and 11 mathematics books. So also find the number of books for each subject which we have found in a box, and the number of books in the box will be 23. So that is the end of this video. We have talking about HCF since morning. So thank you for your attention. I will meet in the next video.